All right, so we remember how to find critical numbers. That's setting the derivative equal to 0 or doesn't exist. So if I take the derivative here, I get 3x squared minus 3x. So there's no place where this doesn't exist, so let's set it equal to 0. Factor out the 3x, so I get x minus 1. So I get x equals 0 and x equal 1 as critical numbers. All right, so if I was to graph this, and this isn't a very difficult graph, so it's a parabola facing upwards, and I know that where the roots are 0 and 1 facing upwards parabola. There we go. So this is the graph of the derivative. All right, so the x-intercepts are the critical numbers, right? Okay, so if I'm looking to find out where the function is decreasing, where the function is decreasing, the f of x will be decreasing when the derivative graph is below the x-axis or negative. So where that is on the interval 0, 1. And we don't include the endpoints because we want where the derivative is negative, so negative is not 0. Okay, so where is the function increasing? So that's where the derivative is above the x-axis or bigger than 0. So that would be on the interval negative infinity to 0, and then, 1 to infinity. All right, so thinking about what's happening, thinking about this first derivative test. So I've got the first derivative test here below. So looking at a critical number c, if I notice that the derivative changes from positive to negative, so what that means is the function is changing from increasing to decreasing, that must mean I have a maximum. So let's look at x equals 0. At the critical number x equals 0, so before x equals 0, I have a positive derivative. After x equals 0, I have a negative. So what I would say is f prime changes from positive to negative. So therefore, I'm just using 3 dots for the word therefore, right? Therefore, f of 0 must be a local maximum because I know what's happening with the function. So then, if my derivative changes sign from negative to positive, then I must have a local minimum because it changes from decreasing to increasing. So if I look at x equal 1, before x equal 1, the derivative is below the x-axis, so negative. After x equal 1, the derivative is positive. So f prime changes from negative to positive. So therefore, f of 1 must be a local minimum. And I don't have an example right here, but if the derivative doesn't change sign, if I have the derivative is negative and stays negative, that would mean decreasing to decreasing or increasing to increasing. So that would give you no max or min. All right, let's look at another one. So we've got this function here. So first find the critical numbers, which means take the derivative. So I have 1 minus 2 cosine of x. So again, there's no place where the derivative doesn't exist. So let's set it equal to 0. So this gets set back to unit circle time, right? So it is just asking for 0 to 2 pi only. So what are the x values where cosine is 1/2? So those two x values would be pi over 3 and 5 pi over 3. Okay, so I want to find the intervals where the function is increasing or decreasing. So this graph of the derivative isn't so hard. I know where the x-intercepts are, right? So this is the graph of cosine flipped upside down and shifted up by 1. So upside down, shifted up by 1. So it's going to look, and then down 2. So it's going to look something like that. F prime of x. Okay, so this would be pi over 3, and this would be 5 pi over 3, because I know those are the critical numbers, right? All right, so use the first derivative test to find the extrema. So extrema just means the local mins or the local max. All right, so I'm looking at the critical number x equal pi over 3. So just communicate to your reader what you're looking at. So I've got pi over 3, and what's happening at pi over 3? F prime is changing, so changes so before pi over 3 it's negative, after pi over 3 it's positive. So it changes from negative to positive. I guess I should have stayed consistent. So negative to positive. So therefore, f of pi over 3 must be a local minimum because it was decreasing and then it went up to increasing. So you need to say that the y value is a min or a max, not pi over 3. So looking at x equal 5 pi over 3, before 5 pi over 3 the derivative is positive, after 5 pi over 3 the derivative is negative. So f prime changes from positive to negative. So therefore, f of 5 pi over 3 must be a local maximum.